This video explores the rise, fall, and engineering extremes of the Soviet Alpha-class submarine, Project 705. It was a vessel designed to be faster than American torpedoes, deeper than American sensors, and louder than a rock concert. In March 1979, American listening posts detected a deep contact moving at impossible speeds. It was fast enough to outrun torpedoes, suggesting the Soviet Union had built something unstoppable. The U.S. advantage lay in sophisticated stealth technologies, allowing American subs to hunt Soviet subs undetected. The Soviet disadvantage was noisy designs, with rattling reduction gears and imprecise propellers, making them easy targets. In 1960, Soviet engineers shifted focus from stealth to raw performance, leading to Project 705. The goal was to overwhelm tracking systems, strike, and escape. The Alpha class was 30% faster than U.S. subs and could complete a 180-degree turn in 40 seconds. Achieving these impossible specs required rethinking submarine operations. Key innovations included titanium alloy hulls for weight reduction, liquid metal-cooled reactors for extreme power, and digital crew systems to reduce the human complement. Building the titanium hull was a challenge. Titanium is strong and light, but impossible to weld in open air. Hull sections were assembled inside hermetically sealed, argon-filled chambers, requiring workers to wear specialized life support suits. The Alpha reactor used a lead-bismuth cooled reactor, offering 3 times the power density. This allowed acceleration from 0 to 40 knots in about 1 minute. The critical trade-off was a 125 degrees Celsius freezing point, meaning the reactor could never be switched off. To minimize the hull size and drag, the crew size was drastically reduced from standard attack subs. Automation managed propulsion, ballast, and torpedo loading. Navigation and other systems were integrated into a central command system. The Alpha class rendered NATO's anti-submarine arsenal obsolete. Torpedoes were too slow, and sensors couldn't track it at extreme depths. The West's response included developing deeper diving weapons and new acoustic tracking systems. The Achilles heel was the solidification trap. In 1972, a minor leak caused the coolant temperature to drop below 125 degrees Celsius, solidifying the liquid metal. This instantly destroyed the submarine, turning the, quote, crown jewel into a radioactive block of scrap. Operationally, the Alpha suffered from cavitation at high speeds, creating deafening acoustic interference. This blinded its own sonar. Furthermore, port facilities lacked the necessary heaters, making maintenance nearly impossible. Terrified by U.S. stealth capabilities, Soviet leadership rushed production before the prototype was fully tested. This mistake resulted in automated systems failing regularly, and only 7 Alpha subs were built, at twice the cost of conventional subs. The Alpha class was a successful failure, demonstrating engineering audacity by pioneering titanium fabrication and pushing the limits of underwater speed. However, it was an operational disaster, unreliable, loud, and economically unsustainable. The Soviets were not trying to build a better submarine. They were trying to invent an underwater fighter jet. The Alpha remains a symbol of Cold War engineering, brilliant, extreme, and ultimately a step too far.